We often set ourselves apart by dividing the world into animals and humans. But humans are animals. I'm sure we have some unique traits that set us apart. We build rocket ships, we wear Lycra, chase Pokemon, and when getting on board a plane, create categories of board and pre-board, which, frankly, I've never understood. I mean, doesn't pre-board refer to the state all of us are in, as long as we're not boarding? But never mind. We humans are intelligent, we're problem solvers, and we're so clever. But are we the only animals that display these traits? I'm Seth Shostak.
I'm Molly Bentley. Welcome to Big Picture Science, produced at the SETI Institute, where researchers investigate the nature and origin of life. On Big Picture Science, we give you the wide-angle view on science and technology, and in this episode, the intelligence of other animals. Has our anthropocentric viewpoint caused us to underestimate their abilities? For example, squirrels rarely, if ever, solve algebraic equations. But could you identify a dozen different spots where you buried nuts last winter?
From dinosaurs to housecats to elephants and chimpanzees, what does it take for us to recognize the intelligence of a fellow animal? Well, primatologist Frans de Waal has some ideas. And if chimps, elephants, or other critters really are intelligent, how does that shape our ethical responsibility to them? Are animals really that smart?
While strolling on a beach in Sussex, England in 2004, a man discovered an unusual pebble among the thousands underfoot. Now, to the layperson, it was just another piece of gravel. But this gentleman was a fossil enthusiast, and he knew enough to give it to this guy.
It's a small pebble. It's brown, and it's roughly 10 centimeters long and 5 centimeters wide. But unlike most pebbles, it's quite knobbly. There's a lot of large lumps and bumps to it. And if you look at the very fine surface texture on the top, there's a series of little tiny corrugations and ridges, and those suggest that there's something slightly more unusual to it than your average pebble.
Only slightly more unusual. Alex Liu, a paleontologist at the University of Cambridge, along with his colleagues in the UK and the US, identified this little brown stone as a dinosaur brain, the first ever found.
To be clear, this is fossilized tissue and a brain, not a skull, which is what usually ends up in museums. That's why it's a first. The squishy gray stuff, if dinosaur brains are that, was pickled in some sort of acidic water with low oxygen, and the tissue was replaced by minerals. Dr. Liu identified it as being most likely belonging to an iguanodon, a big herbivore 19 to 26 feet or 6 to 8 meters in length that roamed continents in the early Cretaceous 133 million years ago.
Dr. Liu discovered that the tissue, the brain itself, was pressed right up against the cranial cavity without the usual low-density roominess of reptile brains, suggesting that perhaps these lumbering lizards were more intelligent than we thought.
A revelation that comes to us thanks to a fortunate accident that happened more than 100 million years ago.
The dinosaur has died and its head has become submerged in a water body, so in a river or a lake. And the brain has decayed and putrefied inside this brain case. And some of the juices, if you like, that are released by the decaying brain contain minerals and nutrients that have actually seeped down and started to preserve the soft tissues at the base of the brain case and preserved some of the soft tissue on the outside of the brain itself.
Okay, now this pebble-sized brain had a skull around it? I mean, that would tell you what dinosaur it came from, right?
Yes, so there's no actual skull associated with the specimen, but the pebble, the unusual shape of it is down to it being a mold of the brain case itself. So if you imagine your skull of a dinosaur in particular, the skull has quite a lot of holes within it because the dinosaur is so big and the head so large that there needs to be cavities so that the skull is not overly heavy and a dinosaur can actually move around. But the brain in a dinosaur is within a tiny compartment within the skull, which again is made of bone, and that's called the brain case. So these brain cases, usually the brain decays away and just leaves a space on the inside. And that space can then be filled by sediment later once the brain itself is removed. And the sediment, if you then were to remove the bone from the outside, the sediment would be compacted into the shape of the original brain. Now that's what has happened in our case, and so the shape of this pebble that we found very closely matches the shape of the cavity that you find in this iguanodon brain case, and that's how we've identified it.
All right, so you know what animal this brain came from, iguanodon. As I recall, there are a lot of those in the museums of Europe. Tell me about an iguanodon. Was it a herbivore? Was it kind of non-threatening? Or and how long ago did this particular brain function as a brain?
So iguanodon is a herbivore. It's around 6 to 8 meters in length, and it's one of the more common dinosaurs that you find in southern England and also in Belgium in the early Cretaceous period, so we're talking around 133 million years ago. It's most famous for having spikes on its thumbs, and it was one of the earliest dinosaurs ever to be described and documented by scientists. And when they first found it, they realized that first its teeth are very similar to the teeth of modern iguanas, and that's how it's got its name. Iguanodon means iguana tooth. But they also found these spikes and thought that they, like in iguanas, went on the end of the nose of the organism. And so they reconstructed it as this four-legged animal with a huge spike on its nose. And it was only when they found complete specimens in Belgium a few years later that they realized that actually, no, it could walk on two legs as well, and the spikes actually go on the end of its thumbs.
If I had spikes on the end of my thumb, I guess I'd have trouble clapping my hands. What function do you think they served?
Well, they are unusual. The most common suggestion is that they might have been used for defense, but it's very hard to test ideas like and hypotheses like that from so long ago when there's no similar organisms alive today.
Now, obviously, this brain isn't still soft. It's like, well, I don't know, a 3D printed brain maybe, but printed in rock, not plastic. Does it show any useful detail?
Yes, so the most remarkable thing about it is that the soft tissue preservation, it's confined to the very outer millimeter or so of the brain specimen itself. The rest is just a sediment infill.
Does it resemble the brains of contemporary animals? I mean, maybe like birds, since birds are apparently, having a bird brain means that you're related to a dinosaur, I assume.
Yes, so there's been quite a discussion in the paleontological literature about whether dinosaur brains were more similar to those of modern birds, which some dinosaurs evolved into, or more similar to those of modern reptiles, which is the lineage from which dinosaurs originally evolved. And birds and reptiles today have quite different brain structure, and the biggest difference is the amount of protective tissue that surrounds the actual brain itself. So if you think of your skull in a reptile, and you have the brain cavity, the space that the brain would have originally filled, in a reptile, the brain can actually fill as little as 50% of that space, and the rest is all protective tissue surrounding it. Whereas in a bird today, you get a brain which is much larger relative to the space and very thin protective tissues around the outside. And there's been papers suggesting that dinosaur brains might be more similar to reptiles, and therefore that these protective tissues took up most of the space, and that the dinosaur brain was actually smaller, considerably smaller, than the cavity in which it's found. And what our specimen appears to suggest, that the dinosaur we're looking at had very thin protective tissues, and that the actual thinking part of the brain, the cortex, took up much more of the space in the brain cavity and is therefore more similar to that of modern birds.
Well, but nonetheless, I mean, this whole brain is pretty small, right? And so whoever originally owned this brain before it became the property of, I don't know, British museums probably wasn't a deep thinker.
Well, it's a difficult thing to quantify. There's one measure of dinosaur intelligence, if you will. It's called an encephalization quotient. Big mouthful. But the idea is that you're looking at the size of a brain relative to the size or mass of the organism. And you can plot this up as a very rough and ready indicator of how smart the animal might have been, and be able to then compare different organisms and animals of different sizes. So Iguanodon has originally been thought to have one of these encephalization quotients, or EQs, similar to that of modern crocodiles. But if we're correct and the brain is larger than we actually originally thought it was, then that will increase by quite a large proportion and would mean that potentially the dinosaur was smarter than we give it credit for. But there are various caveats to that, and one thing is that crocodiles today are not particularly stupid. There's a lot of things they can do in terms of communication and nesting and brooding behaviors that are quite complex and intelligent, if you will. So it's very difficult to quantify exactly how smart these things were.
But it was a herbivore, so maybe it didn't need to be too smart. I mean, eating plants is pretty unchallenging, I would guess. But of course, it would have to stay out of the way of predators. If you had to sort of compare it to something modern, in terms of its intellectual abilities, what animal would you name?
I guess something a bit similar to a cow in terms of the lifestyle that it's living. But as I said, it's very difficult given that there's very few organisms of a similar lifestyle and size that are around at the present time.
Okay, so you have the outer part of the brain, not the inner part, but nonetheless, it's not, it's not like an alien brain. It's a terrestrial brain, and to me that says that in more than 100 million years, Darwinian evolution hasn't done that much to our brains. I mean, is that a fair statement? If I look at other technology, even going back just a few centuries, that can change enormously, but biology just doesn't seem to be big into new models.
Well, I don't think there's a point in changing something if it works fairly well. And so brain evolution has gone on for a long time. There is now, in the last couple of years, there's been fossilized evidence for brains in arthropods from the Cambrian, which is over 500 million years ago. And the structure of those brains is not too dissimilar to the brains of some modern arthropods. So I think if you've got a system that works, then if it's not broken, then why fix it?
Alex Liu, thank you so very much for speaking with us.
That's fine. Thank you very much.
Alex Liu is a paleontologist at the University of Cambridge in the UK. Well, it makes you want to take a second look at all those pebbles on the beach.
You might find a brain. Yeah, there's that. But, we do assume that the dinos were dumb. I mean, you look at kind of lizards and crocodiles and alligators, and he talks about alligators as being smarter than we thought. But, they look kind of dumb, and you figure the dinosaurs were kind of dumb, too.
Oh, careful with that. Seth, what do you think the alligator thinks when it looks at you?
I think maybe it thinks a few thousand calories. I don't know what it thinks, but I didn't think it thought anything, and apparently it does. Also, there's this impression we have that intelligence is an evolutionary development of the last, 50 million years, involving mammals like dolphins.
Recent.
Yeah, recent. And here's a dino brain going back 133 million years that might be much bigger than we thought, suggesting that intelligence was of value very early on in the evolution of life. I'm kind of encouraged by that.
Well, the size of this dinosaur's brain is a surprise, and it may mean that the animal had a higher IQ than we've assumed. Now, any cat owner will be happy to expound with certainty about how clever their tabby is, but maybe Fluffy is even more clever than they realize.
How your house cat has trained you to do its bidding. It's Are Animals Really That Smart? On Big Picture Science. Did you feed your cat today?
And did you feed it the food that you chose and according to your schedule and convenience, or were you subtly influenced?
Here's your dinner, Weeby. You don't like tuna anymore? How about a can of liver and dumplings? What? Not in the mood for that either? What's wrong, Weeby? You're looking at my filet mignon, but that's my dinner. That's a $50 slab of beef. Oh, why am I being so selfish? You're hungry, poor thing. Here you go. Oh, you don't want me to watch you eat? That's okay. I'll go in the other room.
Behind every cat owner are the true brains of the family, which goes to show that the cat's meow really is the cat's meow. Turns out that your feline friend has a special vocalization just for you, although you probably don't realize it, says writer Abigail Tucker.
The Lion in the Living Room is Ms. Tucker's investigation into the Machiavellian machinations of housecats, and that includes her companion while writing the book, her cat Cheeto.
Cheeto probably gained a full pound while I was home writing the book because he had me so well conditioned. One of his things that he does to let me know that he wants something is to nibble my ankles. And so he would nibble my ankles when I was working, and I just almost distractedly get up from the computer and give him a few little shakes of food. And, he really learned how to work that system and became even beefier than he already was during the writing process.
We may think we're smart, but it's the cats that have tamed us, says Abigail Tucker. Taking over our homes is just one step in their march to global domination.
They're really intelligent, and one of the things to remember is that cats and their wild ancestors, or wild relatives, I should say, in the Near East are by nature solitary animals. They're not gifted communicators that are used to being in packs and having social hierarchies and navigating the world through communication. But in recent years, and particularly in the last couple of decades, cats have been living more and more inside of our houses around the clock. I think it's something like 60% of American house cats, or even more than that, are inside all the time. And cats have basically learned through a process of trial and error that if they do certain things, they can condition humans in a Pavlovian manner to do exactly what they want us to do. And so I think it's a form of, marvelous genius that they've been able to kind of work this out on their own terms and develop, in some cases, systems of meows to indicate to their owners that they want a particular thing. And the fascinating thing is that research has shown that you can understand the meows that your cat has taught you and the particular signals it sends. But if you go over to your neighbor's house, you won't be able to necessarily understand that cat's meows and that cat's signals. And that's because this isn't a language that's established across cats. This is a language that your cat has developed specifically to instruct you.
Right, so they've customized their relationship.
Yeah.
I mean, we think of cats as our pets, but your point seems to be that we are their pets. How did this come to be? Was it just, Darwinian evolution because more and more cats were just living with humans?
Yeah, I mean, it's really interesting. Cats basically inserted themselves into the human sphere. It doesn't seem that we ever really had a particular task for them to do or a need for cats. There's some debate about this, but it doesn't seem like they're particularly good at killing vermin, at least to the extent that you would need to kill them to protect food stores or to stop the spread of disease. And basically, when humans became a more sedentary species about 10,000 years ago, we started setting up our first permanent villages in the Near East. Cats just kind of crept into these areas and started eating our garbage. And other animals did this too. Little animals, especially foxes, crept into these settlements too, because we had so much meaty garbage around and we'd killed off a lot of the bigger, scarier predators around. There is something scientists call a mesopredator release, a sudden spike of small predators. But housecats kind of went one step further than the foxes that we still have around our settlements today, and underwent, at least to some degree, the process of domestication. But humans never really put a yoke on them or put them in a cage. They just hung out with us so much that they began to change their brains and, to a small degree, their bodies in ways to sort of better get along in our sphere and to avail themselves of more of our food and protection.
So it is kind of paradoxical, though, because the cats obviously do want to be near us, and yet they are solitary creatures. They're not friendly like your dog.
Exactly. What's fascinating is how adaptable cats are. And one of the most significant aspects of their adaptability is their relationship with us. They can either take us or leave us. They can live with you in a studio apartment, or they can strike out on their own and survive on deserted islands in the subarctic zones, or they can live on volcano cones in Hawaii, or they can live in deserts. They're these amazing survivors, and they can live with us and in certain ways seem to like living with us, but they don't need us, and they especially don't need us in the way that dogs do. Cats can survive outside of our world just as well as they can survive inside of it.
So it's kind of strange because they are solitary creatures, as you note, and yet apparently feral cats form colonies or groups. Do you know why that is?
That's something that I've wondered a lot about, and I think that it has to do with the distribution of resources in a given area. In a natural landscape, like a forest in the middle of nowhere, domestic cats will be more solitary and patrol tracts of territory that are exclusively their own. But in an environment like a city, where there tend to be big, literally dumps of resources, places where all the food is, all the trash is, the cats kind of learn to hang out and to share with each other and get along, especially in these family-based groups. And that's one reason that I called my book The Lion in the Living Room, because domestic cats can take on the social attributes of lions and form almost pride-like groups. And lions, it's worth noting, live in another landscape where resources are not evenly distributed. They live on savannas. So lions kind of gang up together to control these watering holes and these rich, fertile areas in a way that's not totally unlike the way that feral cats might gang up to control a garbage dump.
It's also interesting that you write that the cat's meow, which has become a phrase on its own, the cat's meow is only for humans, that cats apparently don't meow with one another. It sounds like they've figured out a language for us, at least, maybe a one-word language.
Yeah, in nature, it's not that they can't meow. They can meow, but they do not, because they're all by themselves and there's nobody to meow to. In places where there are these wild cats, Felis silvestris libica, these animals are by themselves and they pretty much only get together to fight or mate. And so, this idea of having an advanced vocal repertoire doesn't really serve them. Feral cats apparently meow a little bit more to each other, but really when we see this sort of richness of feline noises, including purring, it's more something that happens within the close confines of the home. And, like we were saying, it's just another example of how startlingly adaptable these animals are and how good they are at surviving in any context. It's like, in a certain way, getting along in our comfortable houses is just as challenging for house cats as, surviving in a barren moor somewhere, because it's just not their natural world. But they're so resourceful that they figure out a way to get along and to get the meat, which is at the heart of their existence. They'll meow to us until they get fed, pretty much, as I learned from Cheeto and his ankle nibbles.
Well, another way in which they might control us, although maybe not quite so deliberately, is the parasite toxoplasmosis. It seems to invade the brain, even among non-cat owners. What is toxoplasmosis and how widespread is it?
Toxoplasmosis is a single-celled parasite that is spread basically through cat droppings. It breeds in the feline intestine, and that's pretty much the only place that it can reproduce 1 billion copies of itself. But then when it goes out into the environment, it can infect any number of mammalian hosts, from humans to humpback whales to, Australian wallabies. And it can have devastating consequences for species, including us. And I think the statistic is something like 1 in 10 Americans have this parasite in a dormant state in our bodies. And the numbers might be as high as 1 in 3 people worldwide.
But still, this could be a dangerous thing, toxoplasmosis, because it seems to make rats less fearful of cats. Maybe it has some effect on our behavior. It might even be linked to diseases. Parkinson's and Alzheimer's have been suggested. It sounds to me like this could be a serious thing, and yet people still have cats.
Yeah, it's a very serious thing. Some scientists think that it has a relationship to various neurological disorders, particularly schizophrenia. But the data there is still somewhat conflicted, but it's definitely an interesting notion that this invisible parasite spread by cats might be sculpting human behavior in ways that we had never anticipated. And the fascinating thing is that just when this news came to light, people had known about toxoplasmosis for quite a while, but they didn't realize until 1969 or 1970 that it was spread exclusively by felines and most usually by domestic felines. And that's actually precisely the moment when housecats kind of took off as more popular pets. And that had nothing to do with the fact that people wanted toxoplasmosis, and I don't think they were being puppeteered by the parasite, as some might argue, but cats were just becoming much more popular. And this information about this sort of potentially devastating parasite that they spread didn't really deter people. And I think that's just kind of fascinating evidence of the power that this other species has over us and their kind of magnetic appeal.
Well, let me talk about another danger that has certainly been well documented, and that is they're killing all the songbirds, right? I mean, I've seen numbers in the millions per day of birds killed by domestic cats. Well, what about that?
Yes, so cats, in addition to gorging on the canned food that we present to them, which also has, an environmental source, but cats on their own are just magnificent hunters and can kill all kinds of animals from lemurs to butterflies. They can catch anything, and that's another source of their amazing survival skills. I think that the songbird stuff, this is such an intense issue because it really divides animal lovers. On the one hand, you have people who love cats who say that, there's no way that my little pet is contributing to this environmental devastation. And then you have the people who, on the other side, are very much involved with the bird world and blame a lot of things on cats. And, I think both sides raise good points. Cats certainly on small islands and even larger islands like Hawaii can drive extinctions of songbirds, and that's really well documented. What's less well documented is the damage that they can do on mainlands like the United States, but again, that's a very hotly contested topic.
Abigail, we're familiar with the idea that dogs evolved from wolves, and not all that long ago. I mean, speaking in geologic terms, anyhow,
Right.
where did cats come from? And, can we learn something? I mean, I know that there were big cats with saber teeth in the La Brea tar pits of Los Angeles. I mean, do we know where cats came from, the kind of cats you have in your home?
Yes, we do. And that's one of the really neat things about them and part of their promise as an animal of scientific interest. Cats come from the Near East and North Africa, this species, subspecies really called Felis sylvestris libica. It's a little cat that looks very much like your pet at home, and often experts can't even tell one from the other. They frequently interbreed with domestic cats. And basically about 10,000 years ago, when we started making our first permanent settlements in the area, all of these little pint-sized carnivores kind of crept into our homesteads and started eating our trash. And what's interesting is that these little wildcats are still alive in the Near East today, whereas the ancestors of dogs, whether or not they were a kind of wolf we would be familiar with or something else, have disappeared. And that's because dogs have transformed so completely in human company that they've really become a separate kind of animal, whereas cats are very much true to the feline blueprint and indistinguishable physically from their relatives today. And so the promise of that is that a lot of scientists who are interested in domestication and the neural pathways involved are curious about, can we compare the domestic cat with its wild relatives and kind of subtract one from the other and figure out the neural pathways that are under selective pressure and figure out more about what this domestication syndrome is and how it came to be. And it's just a really neat opportunity because we know exactly where and when the house cat arose, whereas with dogs, that's really a mystery. And some people say it happened, 15,000 years ago. Some people say 30,000 years ago. They can't agree with where it happened. With cats, it's more clear-cut.
Well, finally, Abigail, cats may be unchanged now for, millions of years, but clearly they're a good model because they come to dominate our high-tech internet, right? I mean, it's said the most popular thing on the internet are cat videos. Why have they become a meme like this? Is it just their baby faces?
I think that we can never underestimate the value of an adorable little face, and people just love to ogle these things. But I do think that there's other basic aspects. One thing that I think that you see online that makes cats such a top predator there, as well as in the real world, is the way that cats move. Now, cats are very solitary, hidden, cryptic animals that tend to lie in wait and ambush their prey. They move very suddenly and in very short bursts of activity. And a lot of the things that you see online that are so appealing, like this famous Japanese cat, Maru, hopping in and out of a box, this sort of explosive pounce behavior, that's nothing but feline hunting behavior that is a sudden burst of activity that fits really well in the sort of short attention span format of the internet. They just make better videos. And because of this explosive ambush hunting style that they have that's really different from dogs. Dogs would tend to hound prey over miles and miles, which sort of doesn't fit into a 10-second viral video quite as well.
I am prepared to yield to our feline overlords. Abigail Tucker, thank you so very much for speaking with us.
Thank you so much for having me.
Abigail Tucker is the author of The Lion in the Living Room, How Housecats Tamed Us and Took Over the World. Well, apparently cats have evolved strategies to make us do their bidding. What other animals have revealed themselves to be cleverer than we thought?
Primatologist Frans de Waal next, and what his answer to that question suggests about our ethical obligation to our fellow fauna.
It's, are animals really that smart? On Big Picture Science.
As we explore the question of animal smarts, including our own incidentally, there are few people outside of Dr. Dolittle who have walked, talked, and studied the extraordinary abilities of animals more than this man.
My name is Frans de Waal, and I'm a professor of psychology here at Emory University, and I also work at the Yerkes Primate Center.
His 3 decades of work with chimpanzees inspired the field of primate cognition. Dr. de Waal has investigated empathy, cooperation, and altruism in primates, as well as intelligence.
Well, intelligence is usually used for finding solutions to problems, especially for new problems. And the term cognition, that's a much broader term. We use that for processing of information. So all animals have to have cognition to process the information around them, but some animals do more complex things than others.
Consider the crows that wait for a traffic light to halt the cars and then hop in front of these vehicles, strategically placing walnuts. So when the light turns green, well, they've orchestrated their very own Nutcracker Street.
Now, Dr. de Waal doesn't question the intelligence of animals, other than perhaps his fellow Homo sapiens. Are we smart enough to know how smart animals are? Is the provocative title of a book that explores our habit of gauging other animal intelligence on the basis of our own.
Can elephants build Tesla coils? I ask you. There you go.
Dr. de Waal urges us to challenge our anthropocentric bias in evaluating other creatures, although, to be fair, we are smarter than we used to be. There was a time when we considered other animals to be simply mindless beasts, guided only by instinct.
Especially in the previous century, we had this very simplistic view of animals, that either they were instinct machines or they had very simple learning processes going on. And everything needed to fit in one of those 2 boxes. And anything that didn't fit, people were very worried about. And so when you had scientists who would say that animals could think, or that they had cognitive maps, or that they could plan ahead, there was an enormous amount of skepticism about that. And I think that has changed. Over the last 25 years, we have now a new generation of scientists who's not so worried about instinct and learning and everything needs to fit in there. They are more open-minded and they are discovering new things. Basically, every week there's a new discovery. And that's because we have a new paradigm, new ways of thinking about it.
It was scientific skepticism, but what I understand through your writing, it was more than that. There was actually a bias against accepting that animals are intelligent. And in fact, we would design experiments that would, in some ways, sabotage our own investigation into this question because we wanted humans to come out on top. Can you give an example of that?
Yeah, there's a lot of testing that has been done, for example, comparing children and apes. And I don't know why apes need to be compared to children, because an adult ape is really not like a child. But anyway, that's what people were doing, and they would do the same test on a child and then the same test on a chimp. And the child would perform very well and do wonderful things and imitate others and understand their goals and so on. And the ape would fail. And then they would conclude that the ape doesn't have this capacity or that capacity. But if you look at those tests, they were done by humans, conducted by human experimenters, which gives the children immediately an advantage because they're dealing with their own species, who talks to them and they understand what they're saying. Whereas the ape is dealing with a different species that it may not relate to so well. In addition, then, for example, the child sits on the lap of mom and gets probably a lot of stimulation from mom, because mothers always want their kids to be the smartest in the world. And the ape is sitting just behind bars without a parent. And so the comparison has been made so many times, and so always the conclusion that the children could do things that the apes were not doing was extremely unfair. And when we started testing apes with apes, so we cut out the human experimenter and we said, can they imitate each other at least? Maybe not us, but can they imitate each other? Or can they recognize the faces of their own species, not recognizing the faces of the human species, but their own species? As soon as you cut out the human, you get much more interesting results, and actually they can do a lot of things that they were assumed not to do.
And this is one of your points, is that the tests were designed around human criteria. And we were thinking as humans think rather than how an animal might think. And we were asking the wrong questions. And you gave an example of the wrong question to ask, which is, in what ways is a chimp like a young human or like an infant human? What's an example of the right sort of question to ask when we're investigating animal intelligence?
Well, the right thing is to sort of look at the world from their perspective. Now, with a chimp, that's fairly easy because we are so much like chimps. We have hands and binocular vision, and we are very much like the apes. We are basically apes, actually, in the eyes of a primatologist. But you go to a species like the elephant or the dolphin or the octopus, that kind of comparisons is very difficult. So with the elephant, for example, the big error was when people tested tool use in elephants, that they thought the elephant should use its trunk. So we humans had decided that if we had a trunk, we would use it to pick up a tool, but the elephants refused to do that. And so the conclusion initially was that elephants are not tool users because they don't pick up a tool that they can use to bring food, clothes, or whatever it was. Until people tested elephants not with sticks to reach food, but with boxes that they could move. And so they hung food very high, and they would spread around a bunch of boxes in the distance, and the elephant would go out of his way to get those boxes and bring them under the food, and then stand on top of them to reach the food. So the elephant was perfectly capable of using tools to reach food, but was not willing to pick up a tool with its trunk, probably because its trunk is also a smelling organ. That's the big difference with the human hand. Its trunk also smells, and if you pick up a tool, you cut off the smell. And so the elephants were not willing to do that. And that's why you always need to take the perspective of the animal to test them, and with animals distant from us, that becomes more difficult.
And wasn't there a case in the many studies done with chimps and bananas where the chimps were unable to get the bananas or didn't get the bananas in the way that you thought that they might, but one chimp came along and just threw a box at the banana to knock it off a shelf?
Yeah, that's the old Köhler experiment. Wolfgang Köhler did these tests where he would hang a banana high and give the chimps boxes and sticks to see what they would do. And he was the first one. He concluded, since the chimps on occasion they would all of a sudden jump up and start stacking the boxes and take a stick and reach the banana, he said they have solved the problem in their head. It's not trial and error learning, and it's certainly not instinct. They have thought about the problem and then solved it. And this was like 100 years ago, and people were so mad at Köhler. There's still scientists so mad at Köhler that he said that they cannot pronounce his name, that they only can hiss his name, Köhler, because they're very sort of upset by what he said. But now we know, he called it insight. Now we know that many animals actually can solve problems with insight. And we had recently, we sort of replicated the test at the zoo with chimpanzees, and we had a female who came up with a solution that I'd never seen before and that Curler had never seen before. Instead of stacking the boxes, she picked up a box and she threw it at the banana, which was very efficient. And that's intelligence. Intelligence is that you solve a new problem in ways that you've never done before, but just by looking at the problem.
One of the things that you highlight is that because we are limited, we, in some ways, now we're learning to broaden our minds as to what intelligence means, but we need to go further and see if there are ways of communicating or perception that animals exhibit that we haven't thought of.
Yeah, so we're very focused on the things that we like in ourselves. So language became a focus very early on. Can we teach language to the apes and things like that? Tool use, we're very good tool users. We were also very impressed by tool use. Things that we cannot do, we're not impressed by. So for example, you may give a bat a dark room with no light at all and a bunch of insects in the room, and the bat will fly around and pick up all the insects and eat them. Very impressive in my opinion, but since we don't do echolocation, we're not impressed by echolocation. We think that's just some sort of sense that they have, some sort of instinct. But actually, cognitively, you ask any engineer who designs radar systems for airplanes how complex this is. It's extremely complex, but since we don't do it, we don't particularly care about it. So we're very anthropocentric in the way we approach these things.
You worked with an ape named Georgia, and I love the story how she would try to spray visitors with water. And
yeah, Georgia. Here,
tell
she
us
lives
what
here.
happened.
She, for 25 years, she was here at our primate center. And I've known her since she was a kid, and she was always a very naughty chimp. Her big hobby was, when there would be visitors, she would go to the water faucet and suck up a lot of water and then wait among the chimps in a sort of innocent fashion, and then all of a sudden she would spray that water at the visitors. And we didn't like that particularly. This is not something we encourage in our chimpanzees. And so the interesting thing one time happened is that she had done that, and I had seen her pick up the water. And I pointed my finger at her, and I said, and I actually said it in Dutch, not in English. I said, "I've seen you." And immediately she sort of looked at me, and she dropped all the water out of her mouth. And so I think she had decided that since I knew what was going on, I was going to prevent her from being very successful on this. I don't think she understands language necessarily. I don't think she understood exactly what I was saying, but I was pointing at her, and my whole attitude was like, you're not going to do this today.
And your conclusion from that is that she did understand body language, because indeed there are some chimps who have learned language, and so you can speak to them in Dutch or in English, and they will understand, if not every word, they will understand what you're saying. In the case of Georgia, your conclusion is that she was understanding body language, and because animals don't have language in the way that we do, they have to be, particularly primates, they have to be very attuned to the language or the communication presented by the body.
Yeah, and actually they're not distracted by language. So humans are often distracted. That's, for example, if you want to watch political debate, we have now had a season of 1 year of political debates in this country. If you want to watch them really, you turn off the sound and you look at the body language. It's very interesting to do that, because language sort of distracts us. We think it's very informative, the language, but actually it also impedes our understanding. Now the apes, of course, or your average dog, they don't know much about your language. They don't pick up all the details of it. And so they look very much at body language, and they're very good at it. And so the apes particularly, you can talk to them and say things to them, and it's almost as if they fully understand what you say, but actually they are paying attention to your tone of voice, your body posture, where you're looking, where you're pointing. And so they're very sensitive to those cues. And the language itself is sort of secondary.
Is there one animal, I don't want to put you on the spot here because I know that you're a champion of all animals, but is there one animal you would say, admit, okay, this animal is not very smart?
There are individual animals. There are individual animals, sometimes in the chimps, but also in dogs. You will meet a dog owner, and you know, most pet owners are very proud of their animals. and very impressed by their own animals. But you will meet on occasion a dog owner who says, well, he's just plain dumb.
Okay, but there's no group of animals like, I don't know, fruit flies, cockroaches,
No, I think all animals
sea slugs.
all animals have the intelligence that they need. They wouldn't be here if they didn't have that. And sometimes what they need to do is very simple. So sometimes all you need to do is wait for a host species to walk by, and you drop on them, and like a tick, you drop on them and you suck them dry, so to speak. That's all you need to do in your life, and you're very good at it. So sometimes it's very limited to what you do. But if you're, for example, a predator, like a lion or a wolf, it's very complex what you need to do, and so it takes a lot of learning to become good at it.
Okay, but a tick, even though the tick has the long journey of climbing up that blade of grass and then standing there waving its arms until you walk by, it's highly adaptive, but it's not intelligent, is it?
No, I wouldn't call that necessarily smartness. The tick has evolved to do these things, and it's all very simple, and it takes a lot of patience to sit there and wait for the host species to walk by. But that's not necessarily a feat of intelligence.
A question about our deep history and our relationship with animals. You write, or in an interview that I read with you, you said that when we were hunters, back when, we respected animal intelligence. But when we became farmers about 12,000 years ago or so, 11,000 years ago, our relationship with animals changed, and we no longer held them and their intelligence in a high regard. Can you say something about that and that changing relationship with animals?
The hunter has a sort of almost egalitarian relationship with the animal, even though he tries to kill the animal. He is in a sort of one-on-one relationship and respects the animal and is impressed when the animal escapes and so on. He's not controlling the animal, and so hunters have a good understanding of animal behavior generally and have respect for them. But then when we became farmers, it became very different. We put them in spaces and we started to control them and to dominate them. And I think at that point our attitude towards animals started to change. We started to look at them as simpler and less intelligent than they actually were. And actually we sometimes maybe even used that to justify for us to keep them that way. So it was actually convenient for our conscience to say that the animals are dumb and they're not worth anything else than what we give them. So when we became farmers, our attitude started to change. And I think what is happening at the moment in the study of animal behavior and animal cognition is that we're returning to more respect. We're becoming a little bit less anthropocentric. And this may have moral implications of how we keep animals. So it may have implications for what we do with them. I think the agricultural industry, the way they treat animals at the moment, is pretty horrific. And so it is about time that we start to think about that a bit differently. And I feel we have an obligation to treat animals well. So I'm not going to say whether we are allowed to eat them or not eat them, or they have personhood or no personhood. That's not something for me as a scientist to decide. But I do feel we have a moral obligation to treat animals better than what we do at the moment. And that whole movement is, of course, going on. We see, for example, the attitude towards circuses has changed, towards killer whales in captivity, towards chimpanzees in research. So I'm very much involved with Chimp Haven, which is a sanctuary where we receive many chimpanzees who were previously in research. So all these attitudes are changing for certain species, and I think this will keep going. I don't see an end to that necessarily.
Frans de Waal, thank you so much for speaking with us.
Thank you.
Frans de Waal is a primatologist and psychologist at Emory University in Atlanta and the author of many books, including Are We Smart Enough to Know How Smart Animals Are?
Well, that's really the question. I mean, what we've heard in the show is that we've had a lot of assumptions about animal smarts, starting with the dinos. We thought that they were maybe not so smart. Maybe they were smarter than we thought.
Yep, and not just the Housecats, which seem to be outsmarting us in our own living rooms. I think that because intelligence reveals itself in many ways, the question is not whether we're smart enough to know whether the animals are smart, but are we smart enough to understand what it even means to be smart?
Well, thanks to the intelligent animals who help us produce this show, senior producer Gary Niederhoff and operations manager Barbara Vance.
Thanks also to financial support from Rena Shulsky David and Sammy David, and to the William K. Bowes Jr. Foundation. Big Picture Science is produced at the SETI Institute, a nonprofit scientific and education organization whose scientists study the conditions on Mars and elsewhere in the solar system. And a big thanks also to our listeners.
Your ears have been attuned to the Big Picture Science episode, Are Animals Really That Smart? And if you'd like to hear more Big Picture Science episodes, well, you'll find them in our archive, bigpicturescience.org.
And if you're a podcast listener but prefer listening to over-the-air radio, because that way your cat can sit on your lap and pick up a little science too, check out the listing on our website of radio stations that carry the program. And if your local station is not on that list, consider letting them know you like the show.
And to reach us directly with your comments, throw in some faint praise and then email it all to bigpicturescience@seti.org.
Honey, dinner will be ready in 45 minutes. Yeah, I'd like to order a large pizza for delivery, sausage and mushroom. Oh, and with extra anchovies, even though I didn't ask for anchovies in the first place.